Hello my students, after that short break, let us proceed with our today lesson, which is based on sonometer. And at this particular time, we're going to look a very special treatment of sonometer case. And I have noted it as special case. Now we're going to look two different cases where at the end we're going to combine them together. We're going to assume the first case where sonometer is hanging free. That means the body, which is this one here, the body which is the mass, this mass here is hanging free. This is the first case. But the second case, we're going to assume that this body is immersed totally into water. Therefore, going to look the difference in frequency on how the hollow box will produce. Remember, the length will be the same. What will be different is only the contents is where the mass is suspended. Now let us begin with the first case where this is hanging free. If this is hanging free into air, tension which will be exerted here is called as tension T1, and the mass of this solid body, we call it mass Sg. S means the mass of solid body, G times G, that means the weight which is acted always towards the center of the earth. Now at this point, we're going to treat this as at equilibrium. At equilibrium, T1 is the same as MSG. For the first case, therefore case 1 at equilibrium, T1 is nothing but MSG. Remember, this is when the mass is hanging free. If that is the case, let us recall the concept of frequency, fundamental frequency. But we know that fundamental frequency is nothing but 1 of 2L under root of tension mu. For this case, our fundamental frequency will be fundamental frequency 1 is equal to 1 of 2L under root of tension. Our tension is tension 1. Mu will remain the same. Mu will remain to be mu. Now if this is the case, this is to say 1 of 2L under root of tension 1. What is tension 1? Tension 1 is MSG, mass of the solid G over mu. Mass of the solid G over what? Over mu. But what is mass? Density times volume. Therefore, fundamental frequency 1 will be equals to 1 of 2L brackets under root, ms is density of solid, volume of solid, G divided by what? Divided by mu. Now you can call this one as equation number 1. You can call this one as equation number 2. The second case, we are going to assume now this body is immersed completely into water or into liquid. Immersed completely into liquid. Now if this body is immersed completely into liquid, the following will change. First, tension will be quite different. Therefore, this is tension 2. The weight will remain to be the same. But remember here within the liquid, we have an upward force, which we call it upthrust. Therefore, upthrust will be exerted here. Therefore, we have another equation now. For the case 2, we're going to have the following. upthrust and tension 2, they acted upward. Therefore, upward force is equal to downward force. Therefore, U plus T2 will be equals to msg. This is for the case 2, where the body is now immersed into the liquid. We need T2. Therefore, T2 is nothing but msg minus U. But do you remember what is U according to Archimedes' principle? U is equal to weight of the fluid displaced. Therefore, here T2 will be equals to msg minus U, which is equal to the same as weight of the liquid displaced according to Archimedes' principle. This is to say ms times g minus W of liquid is like to say the mass of liquid times g. Now what is the mass density times volume? Therefore we have density of solid, volume of solid, g minus density of liquid, volume of liquid, g. But again, do you remember the Archimedes principle when the body is totally immersed in the liquid? Yes. When the body is totally immersed in the liquid, the volume of the body will be equal to the volume of the fluid displaced. Here now, Vs will be equals to V of liquid. The volume of the body, which is the solid, is the same as the volume of liquid. Therefore, I'm not going to omit Vs, I'm going to omit Vl, because both of them, they are the same. Therefore, my equation will be density of solid, volume of solid, G minus density of liquid. Instead of volume of liquid, I'm going to substitute volume of solid, because both of them are the same. This is what? This is T2. Now, after here, we are going now to substitute this equation into the equation of fundamental frequency. Now remember, the fundamental frequency is nothing but 1 of 2L under root of tension of mu. But for this case, we'll have F02 equals to 1 of 2L. Tension is now tension 2 mu for this case here. Now this is to say 1 of 2L under root of tension 2. What is tension 2? Tension 2 is this one here. This is like to say tension 2 is this one. Tension 2 is density, volume. This is like to say volume of solid, G, density of solid, density of liquid. Therefore, T2 is V of solid, G, density of solid, density of liquid, over mu. This is called it equation 2. Therefore, we have two equations here. We have equation 1 and we have equation 2. I think you can see here. We have this as equation 1 and we have this as equation 2. Now what we are going to do here, we are going to divide them. Dividing equation 1 and 2 will have F01 of F02 equals to 1 of 2L under root of density volume Vg of mu times 2L brackets mu over Vsg bracket density of solid, density of liquid. 2L cancel out, Vs cancel out, G get away, mu get away. Therefore, the ratio of F01, the ratio of F01 of F02 is nothing but under root of, this is the same as under root of density of solid over density of solid minus density of what? Density of liquid. Therefore, this is to say the fundamental frequency 1, which is the fundamental frequency. Sorry, this is to say we have this ratio here, which is saying F naught of F naught 2 is equal to ratio of density of solid minus over density of solid minus density of L. Therefore, F naught 1 is F naught 2 times density of solid minus density of what? Liquid. Therefore, this is to say the body will produce high frequency when it is suspended in air than when it is pressed into water, because this into liquid, because this value is greater than this what? This value here. This is the fundamental frequency of air is a certain value times that of water. I hope that is well understood. Let us have a short break.